All right, so let's look at section 2.2, which is polynomial functions, and we should be able to graph polynomial functions. So first off, what is a polynomial function? A polynomial function is in this form here. So we're going to have a single variable, okay, and we're going to have just different um, degrees, different exponents for each of those variables. Okay, so here it says f of x equals a sub n times x to the a sub times x to the n plus a sub n minus 1 times x to the n minus 1. And you're going to see this often, especially when you look at series and sequences and things like that. So what this means is this is just the biggest, okay? The biggest it gets. All right. Same with this one over here. Let me make these smaller. It's too thick. This is the biggest number. Okay, so the biggest degree. And this means the coefficient of the biggest. Okay, biggest exponent. All right, and this is one less than the biggest. Okay, same thing. This is the coefficient of that one. Okay, so for example, you can have f of x equals negative 7x to the fourth plus 9x cubed minus 5x plus 12. All right, so here, the 12, that's our coefficient. Our coefficient is always going to be the one without an x. Sorry, not coefficient. Our constant is always the one without an x. You tell it's that right after break. So this is our a sub 0. And then here, this is our a sub 1. So our a sub 1 is negative 5. And then our x is just x. And here we have our a sub 2, which is 9. And our x. Oh, uh-oh. Look at this. This isn't an x squared. This is x cubed. So in actuality, I did that on purpose. I just forgot that I did it on purpose. So I'm gonna move all of this over because there's a secret. Dun, 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 dun. 0x squared here. So here our a sub 2 is actually 0 and then x squared. So this 9 is actually our a sub 3 and then x cubed. And then we have our a sub 4, which is negative 7. That's the coefficient. And then x to the 4th. So if you want to write it like this, okay, here, the 4 is going to be our biggest exponent. So that's our degree. Okay, this is actually a degree 4. Because that's the biggest exponent. The degree is the biggest exponent. All right, so this is our n. So this is a sub n times x to the n. All right, so it's just another way of writing it that way. And another way of writing that a sub 3 is a sub n minus 1 times x to the n minus 1, because this is the exponent one smaller than the biggest exponent. So 4 minus 1 is 3. And this would be n minus 2, n minus 3, etc., etc., etc. Okay, so it looks kind of messy. Hopefully that's okay though. All right, so we have some functions that we already know. We have a constant function. Remember, this is a degree 0 because there's actually, it's just the constant. And it does have an x, but the exponent for x is 0. And anything to the 0 power is just 1. So that's why it's just a sub 0. All right, that way. Then here, our linear function is going to be a sub 1 x to the first power plus a sub 0. And this is our quadratic function. It looks like a parabola. So it's a sub 2 x squared plus a sub 1 x to the first plus a sub 0. All right, and that's a quadratic. So it says that the 0 function is a constant function with no degrees. The graphs of polynomial functions share certain characteristics. All right, let's put this on the notes. All right, and here are some other graphs of polynomial functions. So this one, as soon as you see it, you can say, ah, this is an odd degree, and then positively coefficient. And we'll talk about how we know that later. Okay. So polynomial functions are defined and continuous. Okay, so there's no hole or anywhere. It's all just goes from left to right. There's no breaks for all real numbers and have smooth rounded turns. So notice how those turns are nice and smooth. All right, it's not sharp like an absolute value. All right, graphs of polynomial functions do not have breaks, so we don't have any holes or gaps in between, and there's no sharp corners. This is an absolute value because it's sharp. All right. So that's what polynomial functions look like and what they don't look like. Let's put that on the notes. Do, 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 do. There we go. On to the next. And here we're going to be graphing. So let's look at this. Yeah, we're just going to graph each function. And if you're thinking, I don't remember how to graph, don't worry. Whenever you don't know how to graph something, the, the thing you want to do is make a table. Now, if you do want to look at it using the transformations, let's do number 8. This does follow the form f of x equals a times bx minus c, and then some exponent. I'm just going to make it a quadratic squared plus d. All right. So this a is going to be a vertical stretch or shrink. Okay. B is going to be a horizontal stretch or shrink. And plus or minus c, that's going to be how much you move to the right or to the left. Translate it left to right. All right. This one you do want to think opposite because of that minus. And that d is going to be translated up or down. All right. So if you remember that if you look at number 8, if you remember that the cubic function looks like this, all right, then you could just say, hey, this is translated left 4 and down 3. So you can actually just move this. Okay, and sometimes for placement tests, they do want you to do that. So here you want to focus on that point 0, 0, the origin, the middle, and then just move it left 4, 1, 2, 3, 4, and then down 3. 1, 2, 3. And that's what it would look like. Okay. Now, if you didn't remember that, that's okay. If you don't remember how to graph a function, just remember, go to IKEA. Why IKEA? Because you want to make a table, an XY table. Remember, f of x and y are the same, okay? Pretty much the same thing. Just put 5 points. Yeah. Okay, now this one's going to be a little different because it is translated left. So you want to start with this -4 in the middle, and then smaller numbers and bigger numbers on the right. So what's smaller than -4? -5. What's smaller than -5? -6. What's bigger than -4? -3. What's bigger than -3? -2. And then you just plug these in. Um, so for example, if you put -6 plus 4 cubed minus 3, -6 plus 4 is going to give us -2. Cubed minus 3 is -8. Minus 3 is going to give us -11. All right, so here we have -11. Then you want to do the same thing with the others. You get -11, -4, -3, -2, and +5. All right, so try that out. And then when you do, you go to the left 6, down 11, and then left 4, left 5, and then down 4, -5, comma 4. Remember, these are points. -6, comma -11, -5, comma -4, -4, comma -3, -3, comma -2, -2, comma 5. So, so yeah, sometimes I forget about that, or before I used to forget about that, but then it's really helpful to remember. Tables are just coordinates. And then we have -4, comma -3. Go to the left 4, down 3. -3, comma -2. Go to the left 3, down 2. -2, comma 5. Go to the left 2, up 5. And there we go. There's our dancing graph. And that's it. All right. If you're wondering if we're going to do another one, we are. I believe we're going to do 10. Ah, let's look at 10. I didn't want to do 10 just because it has this coefficient there for the x. So that coefficient is a vertical, because it's not inside the parentheses. It's a vertical shrink by a factor of 1/8. And then because of this +8 there on the outside of the parentheses, you're saying there is no parentheses. Yeah, the parentheses are around the x when you don't see any. Okay. So this is a translation up because it's positive 8 units. All right, so what are we going to do? Make an XY table. Remember, Y is just fx. All right, what are we going to start with? So you always want to start with whatever you're adding or subtracting to the x. Before we started with -4, because we were adding 4 to the x, we always start with the opposite. Here we're not adding or subtracting anything to the x. Okay, you're saying there's a +8 here, but it's not in the parentheses. You want to put whatever you're adding or subtracting inside the parentheses. So here it's just 0. All right. So that's why we're going to start with 0 and then smaller numbers, smaller and bigger. So -1, -2, +1 and +2. I don't know why I put a plus. And then just plug those in. That's it. That's why tables are nice. If you can't remember how to graph something, just plug into the table. So -2 equals 1/8 times -2 cubed plus 8. -2 cubed is -8 plus 8. 1/8 of -8 is -8 divided by 8 is -1 plus 8 is 7. So we have 7 there. And we plug in the rest, it's going to give us 7.875. I don't know why I put 2 points there. There you go. You do 7.9, that's fine. And if you plug in 0, you get 8. 8.13. If you plug in 2, you get 9. So -2 comma 7. Put left 2, up 7. Put left -1 comma 7.88. 0 comma 8. 1 comma 8.13. And 2 comma 9. All right, so there's a slight curve there. All right, but because of that 1/8, multiplying by 1/8, it is shrinking. So it's getting a little smaller. It looks something like this. It looks a little wider too. Just like when you're cooking or making dough, if you squish it, right, it gets wider. And that's what that graph looks like. Yeah, so make a table. Start with the number that you're adding or subtracting to the x in the middle, and then find the smaller numbers and bigger numbers, plug them in, and then plot the points. Right, so that's that one. Now we did talk about the leading term test. Okay, so remember the lead coefficient. Okay, remember from algebra 1 or algebra 2, like for parabolas, if you have, if your A is positive, then it's going to be an upward opening parabola that opens up. If you have a negative lead coefficient, it's going to open down, right? Lead coefficient. That's the number in front of the variable with the biggest exponent. Okay, so example is like y equals 3x squared. Here, y equals negative 3x squared. So if the a is negative, it opens down. If it's positive, it opens up. And you're going to see that it's the same with the others as well. What do you mean? Now you'll find out. So it tells us the end behavior, like if the a is positive, as x approaches negative infinity, as it goes to the left, then f of x approaches positive infinity, it goes up. And as x approaches positive infinity, as it goes to the right, f of x approaches positive infinity as well. It goes up. All right. Now here are the different types of, these are for even polynomial functions and uh, odd. Okay, so degrees. So this is an example would be y equals 5x cubed. Okay, so if this is odd and the lead coefficient is positive, from left to right it goes up and then down and then up. Okay, ultimately it goes up, it's increasing. All right, so here, negative 5x to the 7th, our degree is odd. And here, this is a negative lead coefficient. So that's why it starts from the top and then ends up on the bottom. And then if we have one that's even, so y equals 5x squared, this is even, this is Steven. I'm just kidding. This is the lead coefficient and it's positive. When it's positive, notice that the end behaviors are both going up from left, going to the left and going to the right. It goes up forever to eternity, to infinity. And here, if you have negative 5x to the 4th, because this is the lead coefficient is negative, That's why it is opening down. And our degree is an even degree. All right, that's how you know that they're both going up or both going down. Okay, so again, odd. One is going down, one is going up, one is going up, one is going down for odd degrees. An even degree, they're both going up from to left and right, or they're both going down. Look at some examples there. And here describe the end behavior. This is actually pretty quick. So if we look at 17, all right, you want to look at the biggest exponent. So here we can actually arrange this. So equals negative 2x to the fifth plus 5x cubed plus 4x squared. So I'm putting this in standard form. That means we're putting it in order, in descending order. So it starts with the biggest, goes down to the smallest exponent. Okay, and that's why we know this is odd. So it's going to be going down on the left side, up on the right side, but it is negative. So because that lead coefficient is negative, it switches it up. So it's going to be going up on the left side and down on the right side. So here, so you look at the degree first. Degree, odd or even. And look at the lead coefficient. All right. So it's odd, so it's one is down, one is up, and it's negative, so it's switched. All right, so here, this would be negative, sorry, f of x. We wrote it as limits. Okay, sorry. So we're going to write these as limits. So limit of h of x as x approaches, and we're going to go to the left first, negative infinity. Then we know as we go to the left, it's going to be going up, positive infinity. So this is equal to positive infinity. And now we're going to go to the right. So limit of h of x as x approaches positive infinity. Positive infinity means up to here. This one is going to be going down. So down to negative infinity. And that's it. All right. So yeah, try number 16. And we can look at 21 as well. Why did I do this? Okay. For 21, if you want to try 20, feel free to. but really just try 16 just for practice. So here you want to, this is in intercept form because these are all, you can find the zeros nicely here. Okay, the x-intercepts. All right, but we want to put it in standard form. So how are we going to do that? We're going to multiply, and there's a lot of work. So x cubed times x plus 1. So we're going to get x to the fourth plus x cubed. And that's going to be multiplied by x squared minus 4. When you multiply that, remember, FOIL. So first, outside, inside, last. That is how we FOIL. Okay. So x to the fourth times x squared is x to the sixth. X to the fourth times negative 4x is negative 4x to the fourth. And then down here, now we're going to multiply these times all of the terms on the right side. X cubed times x squared is going to give us x to the fifth. Remember, when you multiply the same base, you just add the exponents. Then x cubed minus 4 times negative 4 is negative 4x cubed. And put it in order, we get x to the sixth plus x to the fifth minus 4x to the fourth minus 4x cubed. All right. So this is even. And our lead coefficient, it's an invisible 1, invisible positive 1. That's positive. So even means they're both going to go up or down. And positive means they're going to stay going up. So here, we just write limit of g of x as x approaches negative infinity, left, is going to be positive infinity. And limit of g of x as x approaches positive infinity, as it goes to the right, is also going up. It also goes to positive infinity. Left, right, up, and up. There you go. That's it. So try those out. 16 and 20.